in students. So if like we'll increase the conscientiousness, in conscientiousness will be our independent variable. So if like we will vary it, increase it or decrease it. So if that has an effect on productivity of students, that means that they have a causal relationship.
Okay. So you are talking about the correlation.
सर मैंने वेरिएबल सही नहीं लिए क्योंकि आप कॉन्शियसनेस को अपनी तरफ से कंट्रोल नहीं कर सकते, बढ़ा या घटा नहीं सकते. बट इफ लाइक I can think of a variable that I can increase and decrease, then that will be a direct causal relationship. I am manipulating the independent variable and that is causing change in dependent variable. So that I can deduce that my variable is causing the effect in the independent variable. So that is a causal relationship. But if there are just two variables occurring together and I'm not controlling anyone, but I see that if one variable is increasing, other is also increasing, that I cannot say that there is a causal relationship because they can both increase together or a third variable can cause both of them to increase together. I cannot say for sure that there is a causal relationship between the two variables if I'm not controlling one of them, if I'm not manipulating myself the independent variable.
Yeah, in case of the causal relationship, we have to control.
Yes, sir.
And particularly analysis of variance that is useful for the statistical control. Okay. Now, any idea about the analysis of variance when we are applying analysis of variance? Can anybody tell? What is the assumption of analysis of the variance? Yes, Shima.
Hello.
Okay.
Good evening, sir.
Good evening, Shima.
Sir, basically the assumptions are ANOVA is the same as the experimental design. The first assumption of ANOVA is that it maximizes the effect of systematic variance. And the normality and ANOVA.
Yeah, it is considering the.
And it also have.
Yes.
A random sampling.
Yeah, sample should be random. That is okay. And what is the nature of the independent variable? What is the nature of independent variable in ANOVA?
That on interval or ratio scale.
No. In case of the
ANOVA.
No,
sir. IV. For IV.
For IV, this independent variable, what is the nature of the independent variable?
So your voice is cracking.
What is the nature of independent variable?
Hello.
That is the categorical. Okay.
Sir, your voice is cracking.
Hello.
Ji?
What is the nature of independent variable? Kara, am I audible?
Sir, you're audible.
Okay, so nature of independent variable will be the categorical. Okay, and the dependent variable will be metric.
Sir, matlab continuous, right?
Yeah, in case of the dependent variable, that is the continuous,
Okay.
and independent variable is categorical.
Okay.
For example, experimental group and the control group, two groups are there. And you are studying the dependent variable. This dependent variable should be metric. Okay. And particularly, one sec.
Sir, you are on mute. Sir, you are not audible, sir.
Hello. So the basic assumption is that independent variable should be categorical in nature. Okay.
Yes.
And main assumption is the maximization of the differences between the categories. So between the independent variable, for example, experimental and the control group, you have to collect the data in such a manner so that there will be high between group difference and less within group difference. So do you have any idea about the between group difference and within group difference?
Yes, sir. Within group, matlab ki we are recording the same group before an intervention and after an intervention. And between group is we are making two different conditions for two different groups, and then we are comparing the two.
Yes, very nice. And suppose there are more than two groups, then we can think of the ANOVA. If it is only the two groups, then we can think about the t-test.
Okay.
And if there are more than two groups, then we can think about the ANOVA. This is clear to all of you?
Yes.
Okay. And the second assumption is that the dependent variable, that should be metric. That should not be categorical. If both independent and dependent variables are categorical, then we cannot use the ANOVA. ANOVA basic assumption is that the dependent variable should be metric and the data should be normally distributed. Okay, and there will be no outliers. If they have very few outliers, ANOVA can manage it. But more number of outliers, if you have, then you have to remove the outliers.
Okay.
This is clear to all of you? Now you check the data. Okay. This is the data and this is the two groups. Okay. Two means they have received the training and one means they do not have the training. Okay. That means one is the control group and two is the experimental group.
Okay.
So initially, we have to assess the dependent variable. The dependent variable is total score. So this is the dependent variable. Is it visible to all of you?
Yes, sir.
Yes, sir.
Now, here I can find out options. Skewness, cartouches, and many things are there. Initially, I am checking the dependent variable.
Dependent variable is total score.
Total score. Yeah. Okay. So I find very less standard error, no? In case of the skewness, in
Sir, it
case
is
of
not
the
visible.
kurtosis. Acha, this is not visible. Okay. Okay. So this is the dependent variable. 209 data are there. Mean is 36.71. Maximum value is 44. Minimum is 16. Okay.
Yes,
And this is the standard deviation, 4.91. The skewness, it is negatively skewed, but the standard error is less than 1. That means it can be manageable. Kurtosis also less than 1. That is the standard error. Okay, so this is the descriptive statistics. Initially, I have to study the dependent variable. And there is another thing. In descriptive statistics, I can check the frequencies. Total score. I am using the charts. Okay. And it is histogram. So normal curve on histogram. This is visible. Hello.
Yes, sir. Yes, sir, it is visible.
yes, sir.
Okay. So now I click continuous. Frequency table not required. Okay. So now I get the histogram. Okay. And I have noticed the distribution of the normal probability curve. Okay. I have noticed
Yes, sir.
this is the histogram. The minimum score is 16. That lies here. After that, the data starts from here.
Sir, 16 is an outlier.
No, 15 is not outlier. Then we have to check whether it is outlier or not. Now we have to think, this is the histogram. It does not give you the knowledge about outlier. So this is the histogram, and the majority data falls here. Okay. And you will find that is peak of the normal probability curve that also lies here.
So
Okay.
you said that we'll have to check the outliers. So can we do that in SPSS?
Yes, definitely. I will show you.
Okay, sir.
Now I click graphs. Okay. that is chart builder. This is visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
So this is the box plot.
Yes, sir.
Okay. And I am giving this data here. Okay. And I do not find anything about the minimum, above the minimum, sorry, below the minimum or above the maximum. Okay, that means there is no outlier.
But sir, the box has moved. The box is not in the middle.
Box is not the,
Box has moved, na sir, from the center.
yeah,
It
this
wouldn't
is
that
this
mean
is
that
the
there
box
is an
plot.
outlier.
Yeah, you see, this is the box plot,
Yes, sir.
and I have dragged it from here to here.
Yes, sir.
After that, this is my y-axis.
Yes, sir.
So I have taken this total score here.
Yes, sir.
Okay, then I get this box whisker plot.
Yes, sir, but the box is not in the middle, na? The box has moved, na? So I'm saying, isn't that an indicator of there being an outlier?
No, no, no. This is that if there is any data
Yes.
above the maximum,
Hmm.
so this is the maximum line.
Yes, sir.
So above this maximum, if there is any circle or any start sign,
Yes.
then you can think about the outlier. And below the minimum, if you get any circle or start sign, then you can think that is there is some data that is the outlier data. Okay.
Okay. But
So
sir,
that indicates,
why is the box not in the middle there? Why is the box a little
yeah,
towards
so
the upper end?
this is the median value.
Yes,
This is
sir.
the median value.
Yes, sir.
Okay, so median value that is close to the maximum. Okay. And
Yes.
here you can find out some people, they are close to the first quartile.
Yes.
And this is the second quartile and this is the third quartile.
Yes, sir.
Okay. And this is the median. Means I find that is there is no data which can be considered as the outlier. I can consider this data for my analysis.
Okay.
Okay. So finally, I get this is the data. Now you will find there are few numbers of data. Okay, 1, 2, 3. Out of 209, 3 data, they fall below the minimum line. Okay.
Yes.
So now
So
we
these
can
numbers,
check this data because they are below the minimum line. Only 3 data show since ANOVA is maintaining the statistical control and we have large number of data, that is 209 data instead of the 30 data. So we can consider, oh, there is another data that is also 86. Yeah,
sir?
86 number case. And if I want to find out which data, then again I can go to this data. I can click the select cases. Total score, I select. If total score less than 25, okay, less than 25, then I can select this data. Now again, if I click it, analyze, descriptive statistics, frequencies, total score, okay. So I get only the 4 data, okay, less than 25. This is clear. So we can remove these 4 data or we can keep this 4 data. Since our data is very large, that is 209, therefore I can consider in my model. Because I find these particular cases they mainly fall, this is the site from 22 to 25. Majority fall here. Since my data size is large, so I can consider. Therefore, again, I am going to the select cases. And instead of few cases, I will select all cases. Now, okay. Then I can do the analysis about my independent variable. My independent variable is this is my dependent variable. What is my independent variable?
Sir, ARC group. 1 is control group and 2 is experimental.
High and low. Okay, yes. This is my independent variable. So I have to check how many data are there. This is also important. Then I click it, okay. Display frequency tables, I click okay. Yeah, I get 98 people. Their category is 2 and 111 people, their category is 1. Okay. Next. That means in both cases, it is more than 30.
Yes.
Therefore, I can use again, analyze. After that, compared means. In compared means, I find one-way ANOVA. And my dependent variable is this one, this total score. And high and low, that is my factor. Okay. Then I click the options. Options, it is written descriptive. Okay. It is also written means plot. I do not have any missing values. So continue. And then I click OK. So here I find that is my experimental group. Their mean is higher than the control group. Okay, so 40.81 is the mean of achievement motivation. Achievement motivation training they have received. Therefore,
there were only 2 groups. Then why did we do ANOVA? Shouldn't we have done t-test?
Yes. So here you can find out this is the ANOVA.
Yes.
This is the between group sum of square, and this is DF, degrees of freedom, and this is within group sum of square, degrees of freedom 207. Okay, and the total is 208. 209 minus 1. Therefore, this is the DF. And finally, you have noted that is this is the between group mean square divided by within group mean square. And that is the F statistics, F value. And it is written significance 0.000. After that, you can assume 1. That means these two groups are significantly different. And you have to interpret the data by using these descriptive statistics or by using the graph. So this is the mean. Okay. So 1 means my control group and 2 means experimental group. So after the training, we have noticed that since control group has no training, only this experimental group has received the training. Therefore, experimental group performed better in their achievement motivation. In this way, you can compare. So what we have understood, that is, in case of the ANOVA, we have to think about the nature of independent variables, that is, it will be categorical, and there are more than 30 people in each category. And you have to design the research in such a manner so that between group differences will be maximum and within group differences will be less. Okay?
Yes.
And your dependent variable, that should be metric. And you have to check whether your dependent variable has many outliers or not. If there are less number of outliers, you can consider, provided you have good number of data. So more than 200 data means it can be statistically controlled. So this is the mean and this is the standard deviation. And here you can find out, that is, in case of the control group, the within group variability is high. It is 3.72. But in case of the experimental group, it is 2.02. That means within group variability is less. Okay. And this is the average value of the total group, 36.71. The control group has received value less than 36.71. An experimental group possessed higher score, that is more than 36.71. And we have noted the between group difference is significant. Okay. That is, two groups are significantly different. And we can compare this data by using both descriptive statistics as well as the graph. This is clear now?
Yes, sir.
Two approaches are there for making the graph. You can use this chart builder or you can use the legacy dialog. If you go to the legacy dialog, then you can directly go to this legacy dialog. After that, box plot. Then it will be simple. Summaries of separate variables. That is the define. Now I am taking total score. Then okay. So now I get the box whisker plot. This is better by instead of using this chart builder, better you go to this legacy dialog. Okay, this is better. This is called the data visualization. In box plot, summaries for groups of cases. Define. Total score. That is the variable. And high and low. That is the category axis. Okay. Then I click it OK. So what I have received. So this is the control group. And their achievement motive, they have not received achievement motivation training, but they have some level of achievement motivation. And this is the group, experimental group. They have received the training. And you find a lot of the outliers in case of the control group. But in case of the experimental group, you do not find any outliers. Okay. That means within group variability for the control group is high. That theoretically that is sound. And for the experimental group, within group variability is less. This is clear to all of you?
Yes, sir. So I had one doubt in the box where we were filling the data for this chart. There was this section of panel.
Panel.
Yes, sir. What is that used for?
No, this is not the panel data. That is the time series data. But this is not the panel data.
This one is the time series data.
Time series type of data.
Then what is the panel data and like for what?
Panel data, that is the time series data. This is not the time series analysis.
Okay.
That is the over the periods.
Okay. Okay.
But
Got
we
it.
are not thinking about that one. It is the effect of training on achievement motivation, particularly.
Okay, sir.
So this total score represents achievement motivation. Okay. So if you have any good data for your analysis, then you can apply this model. Now, is there any question? Is this box plot clear? Box whisker plot?
Yes, sir.
Okay. So now you can find out, that is, since the outliers are there, box sizes are different. Okay. So I stop share. Okay. Thank you, everybody.
Thank you, sir.
Now I am
Thank you,
closing. Hmm?
Okay, sir. Good night.
Okay.
Thank you, sir. Good evening.
Please, you share your data details to Twinkle, whether you want our data or you want to use your data.
Okay, sir.
Okay.